Today is the first class of the chemical bonding and the molecular structure class. So this is the introduction class of the chemical bonding for the class 11th. So in this class, I will start from the basic about the molecules and the chemical bonds, the covalent bonds and the ionic bonds. So first of all, we have to know about that what is the molecules. So molecules basically forms by the formations of bond between the two atoms. Let us consider here A is a atoms and B is the another atoms. Okay, so A and the B both are the atoms. When two atoms are going to form a bonds, then they are forming a molecule. This is called the AB molecules. So these are the atoms. So these are the atoms, and this the AB is the molecules. So what is happening here? So why these two atoms are going to form a molecules? Because every atoms actually will tends to have the to get a noble gas electronic configurations. So due to that reasons, every atoms can share the valence electrons. So by the valence electrons, by the sharing of the valence electrons, or we can say the donation and the transfer of valence electrons. Okay, so by the sharing of the valence electrons, by the transfer of the valence electrons, they are the forming the molecules. So when the A and the B atoms, when the B atoms both are the sharing, then they are forming the covalent bond. But when the transfer of the valence electron is happening, then they are forming the ionic bond. So between the two atoms in a molecules, there are the two types of the bond is present. One is the covalent bond, and another is the ionic bond. So in this way, they forms the covalent bond and the ionic bond, and they form the molecules here. So to describe the in details about this chemical bonding, so Kosel's and Lewis approach, they have given in 1906. Kosel's and Lewis given a satisfactory explanation of the chemical bonding. What is that? That is the important thing here, chemical bonding with the valence concept. So basically they are saying that the Lewis postulate that atoms achieve the stable octet when they are linked by the chemical bond. The Lewis postulated that the atoms achieve the stable octet when they are linked by chemical bond. For example, we can say that the Cl2, this is the molecules. Here the Cl atoms is bonded by this another Cl atoms. But to describe, we will have the some explanation is that the Cl has the 17 electrons. So if I write the electronic configurations of the Cl is that 1s2, 2s2, 2p. Total is that the 17 electrons. So 2p6, 2p6 and 3s2 and 3p5. So this is the simple electronic configurations of the Cl atoms. But in this configuration, this is the valence shell. So this is the valence shell. So if you see that valence shell, is a 3s and this is the 3p. So 3s2 and 3p, 1 2 3 4 5. So total valence shell electrons 7. So if you see, you can see that in this valence shell this is the one unpaired electrons. This is the one unpaired electrons is present here. So if anyhow you get this another one electrons from the another source, then it can get the octet noble gas electronic configuration. So to get this octet, to follow this octet rule, or to get this noble gas electronic configurations, that's why they are making a covalent bond with this another Cl. How they are forming this covalent bond? So this is the, suppose this is the Cla and another Cl, suppose the Clb. The simple way we can say the electronic valence electronic configuration is that ones. Now both Cls will share these two electrons. How it is like that? So this is the valence electronic configurations. Valence electrons I am writing here. So this is the one Cl and this is the another Cl. So this is the another Cl electronic valence electrons. Now both Cls are the sharing these two electrons. So what is happening here? So this Cl is, this electrons is here, and so this Cl is also sharing this bonding electrons. This Cl also is sharing this bonding electrons. By sharing these bonding electrons, they are forming a covalent bond. This is called the Cl-Cl. So this is called the covalent bond. The covalent bond, because here the bonded electrons, this bonding electrons pair is shared by both Cl atom equally. Okay, because both Cl are the same, that's why this bonding electrons pair is shared by this equally. So that's why this bond is, whatever bond is formed is here, it is called the covalent bond. So by this sharing these electrons, they are forming this octet shell. This is the stable. They are the stable, because once they are the sharing this bonded electrons, now if you calculate this valence shell electrons is the 8. Now this valence shell electron is the 8 in the C2 molecules. So in this way, whence they, so this is the covalent bond situations. But for this ionic bond situations, ionic bond, or we can say it is the ionic compound. How it is like that actually? So for the ionic compounds, what will be happened here? They are actually, suppose here I am taking the for example, I am taking here the NaCl. What is happening? So we know that this sodium and is a Cl. Sodium has the 11 electrons and the chlorine has the 17 electrons. So to get this 18 electronic configuration or the noble gas electronic configuration, it needs the 1 electrons, and also for the sodium case it releases the 1 electrons. So what is happening here? This 1 electrons actually coming from the sodium to Cl. So that's why they are forming the Na plus and the Cl minus. So here what is happening? Here the transfer of electrons is happening. Transfer of electron is happened. Transfer of electrons is happened. So that's why when this transfer of electrons has happened, then they are forming this ionic bond, or we can say it is a, looks like say attractive force is there, ionic bond or attractive force is there. So in this Coastal and Lewis approach, how these NaCls actually forming. So it is a cubic unit cells. So in this way, the sodiums and the Cl atoms are the arranged. So this is the unit cell of. So this is the unit cell of the NaCl. What is happening here? The every corner. Suppose this is the Na plus. So alternatively, it will be the Cl minus, then the Na plus, then the Cl minus. So alternatively, these atoms are the arranged like that. So they are forming the cubic unit cell here. So these are the actually example. These are the actually examples where we can say that by the sharing of the electrons, they are the forming the covalent bond, and the transfer of the electrons, they are the forming the ionic bond. So for that, the NaCl case, in this cubic arrangement, in this cubic unit cell, how they are actually arranged. So, and for the covalent case, the Cl atom, Cl2 molecules, here I have shown here. Now, what is the Lewis symbol? So to know the Lewis symbol, what is happening? First of all, in the formations of the chemical bond, only the outer shell electrons are involved. Then these are called the actually valence electrons. So to know the Lewis symbols, you have to know about first of all the valence electrons. So valence electrons means only the outer shell electrons. Only the outer shell electrons are called the valence electrons. So for example, the oxygen atoms. If I write this electronic configuration, 1s2, 2s2, 2p4. So this is the 1s, this is the 2s, and this is the 2p. So 1s2, 2s2, and this is the 2p4. So this is actually the valence shell, and these electrons are called valence electron. So in the Lewis dot structure, in the Lewis symbol, when we will say, when they will ask that you write the Lewis symbol of the oxygen, then you have all the oxygen is the atoms, and you have to mention only the valence electrons. So here the valence electrons is 6. So total valence electrons is the 6. So you have to mention the valence electrons 1, 2, 3, 4, 5, 6. So this is the Lewis symbol for the oxygen case. So another case, suppose the lithium. So lithium, the Lewis symbol is lithium dot. Beryllium has the 2 valence electrons. So this will be the valence symbols for the beryllium case. The boron has the 3 unpaired electrons. And these electrons are the valence shell. So when this is the 3 unpaired electron, so the Lewis symbols will be like that. For that carbon case, and carbon also has the 4 valence shell electrons, so the Lewis symbol will be like that. The nitrogen case, it will be 5 electrons, so it will be like that. So in this way, you have to the first of all know what is the actually Lewis symbols for that the what atoms. So now after that, there is the some significance about this Lewis symbol. In that case, in the periodic tables, the highly electronegatives and highly positive elements are separated by the noble gas. Why they are the saying that? Suppose so first of all, I am writing that postulate. The highly electronegative and highly electropositive elements are separated by noble gas. Second postulate is that for the formations of the Na to Na plus cations, it release the 1 electron. So by the loss of 1 electrons, to formations of the cations. Similarly, the formations of the anions by the gaining of one electron. Another postulate is that the negative and the positive signs by thus formed that attains actually the noble gas configurations. Like this is a calcium. Now, when this calcium is releasing the two electrons, it is forming the calcium plus 2. So if you see that electronic configurations of the calcium plus 2, it looks like the argons, argon 4s2. So this is the argon 4s2, and when they are the two electrons are the leaving, so then the electronic configurations looks like the argons. That's why we are saying like the fluorine, when it is the gaining the one electrons, then they are forming the F minus anions. Now the fluorines has the electronic configuration is helium 2s2 2p5, but the F minus has the electronic configuration is helium 2s2 and 2p6. So that's why we are saying the highly electropositive and the highly electronegatives, both the atoms are separated by this noble gas. And another point, the bond formed as a result of the electrostatic attractions, it is called the ionic bond. Already I have told here. Now octet rule. What is the octet rule? According to octet rule, atoms can combine either by transfer of valence electrons from one atom to another, or by so the transfer means or by sharing of valence electrons in order to have an octet in their valence shell. For the Cl2 molecules, again the Cl atoms has a 7 valence electrons, so this is the Lewis symbol of that one Cl atoms. And for this another Cl atoms, this is the another Cl atoms, so they are forming a covalent bond by the sharing of electrons, bonded electrons. So here it is also the 8 electrons. Now the 8 electrons, the valence shell is equal to 8 electrons, and they are forming the Cl-Cl. So this is the covalent bond. And each combining atoms contributes at least the 1 electrons to shared pairs. So here if you see, so they are giving the at least the 1 electrons. So each combining atom contributes at least 1 electron to the shared pair. So here also they are forming, and they are the two the Cl atoms are the actually sharing, and they are the giving the 1 electrons and 1 electrons to make a covalent bond. Another point, the combining atoms attain the outer shell noble gas electronic configuration as a result of sharing of electrons. So here if you see in the previous slide that the electronic configurations in this electronic configurations of that Cl atoms in the Cl molecules, the valence electronic configuration is the noble gas electronic configuration. So it has the octet, it has the 8 electrons in the valence shell, so they are the forming the actually octet rule, and in these molecules every Cl atoms follow the noble gas electronic configuration. That's why they are the stables and they are exist in natures. So octet rule is saying that every atoms, whereas they are going to make a covalent bond, and by the sharing of the 1 electrons they form the covalent bond, and they also follow the valence electronic configurations will be looks like the neighboring noble electronic configurations. Now here I will draw some the Lewis structures of the molecules according to this Lewis symbol. First of all, like the CCl4. Okay, so in this CCl4 molecules, if I draw the Lewis structures of the CCl4, then you have to first consider this C is the central atom. This is a central atom. The carbon is a central atom. So you have to first designs this has the 4 valence electrons, 4 the valence electrons, and this is the Lewis symbol of the carbon atoms. Now you have to draw the Lewis symbol for the Cl atoms. So now the Lewis symbol of the Cl atoms, we know that it has the 7 valence electrons. So this 7 valence electrons, the Lewis symbol for the Cl atom looks like that. So for that Cl atoms, I am drawing here this electron cross, and for that carbon atoms, I have drawn the electrons as a dot. So this is the Lewis symbol for that chlorine atom, and this is the Lewis symbol for the carbon atoms. Now in the CCl4, if you see, this structure is tetrahedral, and this bond is the covalent bond. This bond is the covalent bond. So this is the covalent bond. That means the bond electrons is shared by the chlorine atoms, and also the bonded electrons shared by the carbon atoms. So here, first of all, the bonded electrons will share by these carbon atoms, that is the circle. Inside this circle, if you see, the chlorine has also the 4 valence electrons, and 4 electrons, another 4 electrons is coming from the 4 different Cl atoms. Now this carbon has the 8 electrons in the valence shell. Now the carbon is following the octet rule, and the carbon is following also the noble gas electron configurations. So similarly, this bonded electrons by share by the Cl atom, this bonded electrons also share by this another Cl atom, this bonded electrons is shared by this Cl atom, this bonded electrons share by that Cl atoms. So if you see that every carbon, every Cl has also the 8 electrons in the valence shell, carbon also has the 8 electrons in the valence shell. So they are actually follow the octet rule. So that's why they are forming this, every Cl atom is covalent bond. Every Cl bond is the covalent bond. Now for that CO2, for that the CO2 molecules. So the structure is looks like that. It has the 4 valence electrons on the oxygen atoms. So now you first of all have to draw the Lewis dot structures, or so this is the Lewis dot structure of the oxygen case, and this is the Lewis dot structure for the carbon case. So again I am drawing the Lewis symbol of the oxygen. So now when they are forming the double bond, that means that the 4 bonding electrons are the presents. So this is the 4 bonding electrons. In case this is also the 4 bonding electrons are the sharing by the oxygen atom, and this 2 double bond. So there is a 8. So this is the 8 electrons. Here also the 8 electrons. There is also the 8 electrons. So every atoms has follow the octet rules by the sharing the bonded electrons. So these are actually the Lewis dot structures. Now for that N2 case. So we know that this structure, this looks like that. It has the two. So this is the 3 bond is there, 1 sigma and 2 pi bond. So there is a triple bond is there between these 2 nitrogen atoms, and every nitrogen atom has a lone pairs. Now if you see, first of all you have to draw the Lewis symbol for that nitrogen case. So these are the Lewis symbol for that nitrogen case. Now they are forming the triple bond, so we need the 6 bonding electrons. So here if you see, this is a 6 bonding electrons shared by this 1 nitrogen atom. This is the 6 electrons by the shared by the another nitrogen atoms. So this also the 8 electrons, this also the 8 electrons. Okay, so valence shell has the 8 electrons, 8 electrons. and they are forming this octet rule. And there are some points that negative charge would means the addition of one electrons. When we are saying this is a negative, suppose negative charge means one negative charge means addition of one electrons. So this is the one negative charge, and positive charge means loss of electrons. So for case, in case of, suppose for example here we can say the CO3 2 minus. So here this 2 minus, the negative charge is the minus 2. So the negative charge equal to minus 2. That means the addition of 2 electrons. Suppose the NH4 plus. So this is the charge is, so this is the positive charge. So that means the loss of 1 electron. So if I draw the Lewis presentations of the CO3 2 minus, what will be happened here also? First of all, you have to know the structure 2 minus. Now this 2 minus, this is the addition of the 2 electrons. Now the between this carbon and oxygen is the more electronegatives. So this negative 2 charge will be, these 2 extra electrons will be present on the oxygen atoms. So what will be happened here? There will be these 2 lone pair, we know that, but for that oxygen case there will be the 6. So if I draw the Lewis dot structure for the CO3 2 minus, it will be happened like that. We know that oxygen has the 6 valence electrons. So this is the 6 valence electrons, but there is a 2 minus. So 1 electrons will be have on the 1 oxygen atoms. So that's one, that ones, and another oxygens also will have the 1. So that will be this valence, actually valence electron. So this oxygen actually minus minus, so O minus, this is the O minus. Now this is the carbon. Carbon has the 4 valence, so there is the 4 valence is there, and this oxygen is the neutral, so it has actually 6 valence electrons. Now this is the bond is forming, and this is also the bond is forming, and this is the double bond is forming by sharing this electron. Sorry, it will be like that, and these oxygens will be forming this sharing by electrons. So here what is happening, the first of all you have to know the oxygens is more electronegative than carbon. That's why these 2 negative charges will be on the oxygen atoms. So here the 2 oxygen atoms, this is the actual negative charge, this is also the negative charge. If I do not write this overall negative charge, then the structures will be like that. Okay, so in this array you have to draw the Lewis dot structures of the ionic compound NH4 plus CO3 2 minus. So we can say also the for the neutral and also the ionic compound. So here I will stop the first class. So this is the introduction class, how to draw the Lewis symbol and how to draw the Lewis dot structures. So before going to this Lewis dot structures, you have to know the about this octet rule. What is the octet rule? And basically the octet rules, they actually follow the neighbors the noble gas electronic configurations. So by the sharings, by the transfer of the electrons, they follow always the octet rule. So here I will stop the class. So in the next class we will discuss about another topics. So thank you very much.